Hi, this video is about tangents to circles. Now, what we're going to look at today is, first of all, what a tangent is. Okay? So in the context of circles, a tangent is a line that touches the circle at just one point. So we've been used to chords, which cut through the circle. We've got diameters and we've got radii. Tangents is a different type of line that interacts with the circle, and it only touches the edge of the circle at one point. So I'll show you that just now. Okay, so make sure you're copying that into your jotter. A tangent is a line that touches the circle at one point, and then what we're going to do is we're going to look at this diagram here, and we're going to kind of identify the different pieces on it that are going to help us to figure out missing angles and so on. Okay, so first thing we can identify is this line here. So this is what we're talking about. A tangent is a line here, and it touches the circle just at one point. So it comes past the circle and just touches the edge of it. Okay, so if we draw out this diagram, if you want to pause me just now and copy this diagram into your notes jotter, and then we're going to put the labels of the things on it together. Okay, so this here is our tangent. So that's the tangent, alright? And this line here goes from the centre of the circle to the edge of the circle. We know that that is called the radius. And the important thing to notice here is when the radius and the tangent meet, we get a special kind of angle. Okay, we get a right angle. So we can mark that in here like so. Now, this always happens, right? So when a radius and a tangent intersect, you always get a right angle. Okay, so we're going to write that down as well. All right. So we're going to write when radius and tangent, and we'll use a fancy math word, we'll say intersect. On the circumference of a circle a right angle. Is formed. Okay, and that's going to be a kind of way in for us to work out lots of different problems to do with angles and lengths and so on with circles and tangents. Okay, so we can see here that we've already got 25 degrees in here, right? So let's say, for example, that the question had asked us to work out the size of angle AOB. Alright, so angle AOB, what is that? Right, so AOB, remember you trace it with your finger, and that gives you the angle, so it's going to be this angle here. Now, we know that this 90 and the 25 and that angle must add up to 180 degrees. So, therefore, if we do 90 take away 25, which gives us 65, so 90 take away 25 equals 65 degrees. Because remember, we were talking before about how these two angles, the two acute angles in a right angle triangle, will always add to 90 as well, right? So that's really important. So, because of the fact that we know, okay, so remember, in the first instance, you will not be given this, right? You will have to know this fact and then know that that's a right angle, okay? I've just drawn it in because we should always draw it in the diagrams to help ourselves, okay? So this is a 90 degree angle, this is 25, so that must be 65 degrees. Okay, so that's how we work out, excuse me, a missing angle when we have a tangent which forms a right angle triangle with a radius. So we've got the radius and the tangent forming the right angle, and then we've got our hypotenuse here of a right angle triangle which joins these two up. We're forming a right angle triangle, as you can see, and we can therefore work out the size of that angle there. Okay. So this is a second example we're going to look at. This time we're going to find a length. So we're not going to find an angle using tangents to a circle, we're going to find a length, okay? So this time we actually have two tangents, if you look. We've got BC here as a tangent, see? And then AB is a tangent as well. We've been given some lengths, so we've got 8 centimetres and 6 centimetres, and the question says, find the length of OB. Now OB here is a dotted line, okay? So the first thing we have to establish is, where is the right angle? right? So this is a radius, this is also a radius, so that means that we're going to have a right angle here, where it intersects with the tangent, and we're going to have a right angle here, where the radius and the tangent meet. Now, I'm going to use the top triangle. There's actually two right angle triangles if you look here, see? There's one at the bottom and one at the top. So I'm going to use the top one just because there are numbers on the top one, right? That's the only reason. I could use the bottom one. This side is 8 as well because these are equal, and the radiuses, or the radii, sorry, are also equal, so this will be 6 as well. Because the numbers are here, it's nice and convenient, so I'm just going to use that. Now, a strategy that I found works really well when doing these questions is, if we can kind of extract the right angle triangle, it makes it a little bit easier for ourselves, okay? So, we've got a right angle triangle here like that. Okay, so I've just taken that triangle and I've drawn it again over here, and this is our side OB that we're looking for. Alright, so we're going to use Pythagoras' theorem. This is a hypotenuse because it's opposite the right angle. So, OB squared is going to be equal to 8 squared plus 6 squared. So OB squared, if we add that up, that's 100. I'm sure you can see where this is going. So OB is 10 centimetres. So remember, what I've done is, I have used the fact that a radius and a tangent intersect at right angles all the time to prove that there's a right angle here, which has then allowed me to use Pythagoras' theorem to figure out the length of OB. Okay? So without knowing that a tangent and a radius meet at right angles, I wouldn't be able to get that, and then I wouldn't be able to use Pythagoras' theorem because he only works for right angled triangles. Alright? So just to go through it one more time. We've used tangent and radius intersect at right angles. So that's a right angled triangle here. And then we've got one here. We're going to ignore this one. We don't really need it. It's an exact copy of this. This is a line of symmetry. But we are asked for the length of OB. So what I've recommended we do is we take our diagram out of this whole situation to make it a little bit more simpler to understand what we're going to do. I'm now going to use Pythagoras' theorem. I've got the hypotenuse. Other sides are 6 and 8. That's one of the Pythagorean triples. So if I work that out, 8 squared plus 6 squared is 100. And then the square root of that is 10. Now I have taken lots of shortcuts with this little Pythagoras step. If you go back and look at the Pythagoras video, you will see how to do Pythagoras' theorem in a bit more detail. But I've taken it a little bit quicker, just to kind of abbreviate this video a little bit if I can. Okay, so I hope you understood that. Remember, you can pause, rewind and do all that stuff to go